All right, so one more example of the multiplying types, which are pretty easy. Okay, we'll just do 6x and 8z. All right, so all multiplication, no adding, no subtracting. Multiply the numbers together, 6 times 8, 48. xz, stick those together, drop parentheses, number in the front. Okay, now, the third type of problem, or I guess the third concept really, is some algebraic properties. And there's a lot of different properties. So we're only going to go over the three most important ones. So properties. We'll start with, and you might have heard these before, commutative property. And we're going to have one for addition, and one for multiplication. Think about commuting. If you know what commuting means, then this property makes sense. So when you commute, say, to work, you leave your house, you drive to work, so you go one direction. And then on the way home, you go from work back to your house, so you retrace your steps. You just go in opposite directions. And that's what the commutative property just switches the order of something. So the actual property for addition is a plus b equals b plus a. You could switch the order when you add. In other words, adding, you can add in any order that you want. And then of multiplication, it might look like AB is the same as BA. You can multiply numbers in any order without changing the outcome. Examples. Would be 5 plus 3 equals 3 plus 5, for example. They're both going to be 8, so it doesn't matter. And you might even add a bigger list of numbers. You might have 4 plus 1 plus 3. That's going to be the same as 1 plus 4 plus 3, right? I just switched the order of the first two. So in any case, I'm going to get 8, right? 5 and 3, 5 and 3. So they're both going to be 8. Multiplication, 2 times 7 is the same as 7 times 2. They're both going to be 14. Or 3 times x is the same as x times 3. All right. So the next property is associative. This is the one that is remembered the least. Associative property. So just think about what it means to associate. When you associate two things, that means you kind of keep them together in your mind. They're stuck together. So the associative property looks like, so of addition, it is a plus b plus c. Let's say I parentheses the a plus b. That means in PEMDAS you would have to add those first. Well, the result of that is going to be the same as a plus parenthesis b plus c. I could group the last two here and group the first two here, and the result is going to be the same thing. So really what changes with associative, you change the parenthesis location, but the sequence is the same, A, B, C, A, B, C. parenthesis is the only thing that moves. So only the parenthesis changes location. Okay, and then of multiplication, would be ABC equals ABC. So on the left side, I associate the A and B together first, so I'd have to multiply those first and then by C. That's going to be the same result as if I associate the B and C together, do that first, then multiply by A. So examples. I could take, let's say, 7 plus 2 plus 3. 7 plus 2 plus 3. Notice the numbers are in the same order. But on the left side, I'm going to associate the 7 and 2. In other words, you're grouping them. And on the right side, you're going to associate the 2 and 3. Well, this would be 9 plus 3, which is 12. This would be 5 plus 7, which is 12. Okay, and then an example with multiplication. 5 times 3, let's say times 2, equals 5 times 3 times 2. Same order, 5, 3, 2, 5, 3, 2. But the parenthesis changes location. This would be 15 times 2, right, which is 30. This would be 6 times 5, which is 30. Okay, so that's the associative property. And then the last one, which you've probably learned, I'm guessing at some point, it's the distributive property. Okay, and the distributive property goes A times B plus C. In other words, you have a term on the outside of a parenthesis, then you have a parenthesis with more than one thing in it, separated by a plus or minus. That's going to be A times B plus A times C. And here's an example. We'll do examples over here. Example 3 times x plus 4. That equals 3 times x, 3x, plus 3 times 4, or 12. So there's a distributive property that has addition in it, and then there's a similar version for subtraction. Now, if you keep change, it's all going to be the addition one. But the subtraction one goes AB minus, right? A times B minus A times C. And the example would be 4y minus 6. So if I distribute that, I'll get 4y minus 4 times 6, 24. Okay, so that is the distributive property.